Good evening. Today I would like to explain my conference paper title is Assessing the Role of Machine Learning Models in Groundwater Contaminant Monitoring and Management. Here I am taking a groundwater as input from various countries. I have collected the groundwater data set. On that groundwater data set, I am applying a machine learning models to find the contaminant concentration levels of PFAS. I am using machine learning models. And welcome to International Conference on Adelaide 2024. And welcome myself, Dr. Asadi, and my colleagues are Dr. Alvin Lal and Professor Laureate Ravi Naidu. And today's my agenda contents of conference paper paper contents are introduction, aim or objectives, methodology, results, discussion, future directions, conclusion, references. And coming to introduction part, so here in groundwater contamination poses significant environmental challenges and public health related challenges. So we are handling those challenges by performing machine learning on groundwater data set by using conventional or traditional methods for managing groundwater contaminants have limitations, issues, challenges regarding accuracy, efficiency, and scalability. Then that's why, in order to increase the accuracy, efficiency, performance, we are using artificial intelligence, machine learning, deep learning techniques on groundwater data set in order to predict and detect contaminants concentration levels of PFAS. So we have collected various literature survey papers, and we are finding information from previous studies. What are the common drawbacks we have identified? So from this table 1, literature survey of groundwater contaminant monitoring and management. Here are 7 columns like author details, common drawbacks, existing system, proposed system, data sets used, and what type of tools and techniques they have applied, and what is the future work. So we have collected a total 10 closely related to my topic, and we have identified common drawbacks, and various authors, they have proposed their own algorithms and data sets from various repositories like UCI repository, GitHub repository, Kaggle repository, and tools and techniques. Some authors, they have executed in machine learning, deep learning, AI techniques, statistical techniques, and they have used their own tools like SPSS and Weka and Java, Python, various tools they have used. I have collected all the common drawbacks, and I am avoiding those drawbacks in my proposed system by using machine learning algorithms. This is the groundwater data set and contamination risk data set, and this is the synthetic data set I have created, and the final output of this contaminant risk target is low or medium or high. That is the groundwater PFAS prediction. And machine learning techniques playing a vital role in order to find out the contaminations of concentration levels of groundwater. So these models provide and enhancing decision making capabilities, improving accuracy and faster processing times. Then the objective of what is the objective of my research is to assess the effectiveness of various machine learning models in groundwater contaminant monitoring and management. Here I am choosing a neural networks, decision trees, regression models, and we are assessing which model is better for improving the accuracy and contaminant detection, environmental monitoring and management strategies. Finally, our objective is to improve the accuracy and enhancing decision making. Then these are the survey papers we have collected from various sources: groundwater contaminant monitoring with machine learning techniques. And what is the case studies we have observed? Nearly 10 case studies we have observed, and countries from groundwater models they have used methodology, why this application, what are the results, and what is the reference number. So in this methodology, it addresses the contamination issues by analyzing case studies and data and performing comparative analysis to manage groundwater pollutants. First, we are collecting the groundwater data set, then pre-processing, then we are performing evaluation, model selection, then we are evaluating the experimental, then model analysis, and finalizing, then finally that output of the model collection. So in this methodology we are choosing best approach, then it examines all the case studies and empirical data, and finally we are analyzing comparative analysis to show machine learning advantages over conventional methods or advantages of machine learning in managing groundwater pollutants. So this is the architecture which comprises the software and hardware components and connections among them. The first step, training data, we have collected 70% of the case studies for training data and 30% of testing data. Then we are choosing the machine learning algorithms, then we are validating the data, and we are choosing the various machine learning models, best model, and finally we are selecting that model. So these are the steps we are following: data collection, after that data pre-processing, then model training 70%, 30% testing, then model evaluation, decision making. Then these are the results. Finally we got it by applying deep learning emulators like CNN, RNN, LSTM, artificial neural networks, and optimized models enhance groundwater monitoring accuracy and efficiency. Finally, we have applied advanced deep learning methods, and we got very good results of groundwater contaminants concentration levels, and finally we have enhanced monitoring and accuracy and efficiency. And these are the model applications we have demonstrated in our work by using deep learning emulators like deep neural networks model, convolutional neural network model by using ModFlow, optimized machine learning models. XGBoost is a machine learning model, and we are discussing of results in the case of model applications like deep learning, DNN model, convolutional neural network, and XGBoost, etc. And the future direction of our research is we are recommends improving machine learning algorithms by integrating real-time data and broadening their use in various environments for enhancing groundwater management. So refining machine learning algorithm is one of the future direction. Integrating real-time data, expanding applicability, better groundwater management, etc. So the final conclusion of our research paper, it performs machine learning models outperform than traditional or conventional methods in managing groundwater pollutants, especially in simulating contaminant movement and optimizing monitoring networks. And these are the references I have used, 10 references. And thank you for giving me this wonderful opportunity. If you have any queries, you can ask me right now. I'm going to clarify.